9 videos ago, you thought NLP was one big black box. Now, pull out a receipt from your pocket, charge $140 at Whole Foods on March 14th to card ending 4832. You can walk that sentence through the entire Lecture 7 pipeline in your head. Tokens, part of speech tags, a parse tree, named entities, word senses, semantic roles, Coreference, even the MWE card ending. You've earned a receipt. Video 10 of Lecture 7, The Closer. 9 videos worth of the core NLP task inventory, walked one more time, fast, dense, with the paper citations that should stick. Plus a preview of Lecture 8, where we finally leave the sentence behind and start thinking at document level. Video 1, Open the Belt. 6 classical stations: Tokenize, POS, Parse, NER, WSD, SRL. For 30 years, each station was its own research field. Transformers appear to have deleted the belt, replaced it with one big end-to-end model. Actually, the belt lives inside the hidden layers, and it still runs explicitly in every production spacey or stanza pipeline. Today's puzzle. If you asked a linguist in 1990 what NLP is, they'd say, this pipeline. If you asked a machine learning engineer in 2026 what NLP is, they'd say, a transformer with a text input and a text output. Both are right. The pipeline is the way language is structured. The transformer is the way we now compute over language. Lecture 7 bridged those two answers. Today's 3 beats. First, the classical belt recapped. V2 through V7. 6 stations, 6 ideas. Second, the beyond the belt edge cases. Coreference and multi-word expressions. V8 and V9. Third, Lecture 8 preview. Document-level tasks, summarization, speech, translation, where sentence-level analysis breaks and document context takes over. V2, tokenization, not pre-processing, a task, 6 landmines, contractions, punctuation, URLs, hashtags, CJK, emoji, modern subword tokenizers, BPE, word piece, sentence piece, sidestep most word boundary problems but create new ones like the strawberry letter count bug. Practical rule: use the tokenizer that shipped with your model. Never cross the streams. V3, POS tagging. Penn Treebank tag set. Marcus, Marcinkiewicz, Santorini, 1993. 45 tags, 3 generations of taggers. Church, 1988. Rule-based Brill, 1995. Neural Bonnet, 2018. 97% solved. The 3% left is ambiguous words like flies, leaves, saw, and garden path sentences like the old man the boat. V4. Parsing. 2 rival ways to draw the skeleton. Constituency trees. Chomsky lineage versus dependency arcs. Modern default. PCFG era. Charniak 2000. Collins 2003. Head lexicalisation pushed accuracy over 90. Neural parsers hit 95 LAS. Garden paths and PP attachments still leak through, because those are semantics dressed as syntax. V5. Named entity recognition. Bio-tagging. Ramshaw and Marcus, 1995, turns span extraction into per-token classification. CoNLL, 2003. Cheong Kim Sang de Mulder is still the benchmark, with types PER, org, LOC, MISC. BERT-based NR hits 93 phone by using contextual embeddings. Same Paris, different vector, different tag. V6. Word sense disambiguation. WordNet, Miller 1995, gave the field a sense inventory, 200,000 English senses. Lesk 1986 was elegant but mediocre, the most frequent sense baseline held for 40 years. Then ELMo and BERT solved WSD sideways. Contextual vectors for bank near river cluster, separately from bank near deposit. Task solved by pre-training. V7. Semantic role labeling. PropBank. Palmer, Gildea, Kingsbury, 2005. Every verb gets a frame file with numbered arguments. FrameNet, Fillmore et al., 1998, organizes verbs into shared frames like commercial transaction. Modern SRL hits 90 phone, and every triple in Wikidata is downstream of SRL style analysis. V8. Coreference. Anaphora is the backward-pointing pronoun. Coreference is the broader task of linking any two mentions that point to the same entity. Hobbes, 1978. Walk the Parse Tree. Lesk, Davis, Morgenstern, 2012. The Winograd Schema Challenge. 270 pairs engineered to require world knowledge. Lee et al. 2017 and BERT-based successors cracked it, not by reasoning, but by pre-training exposure to millions of container object fit patterns. V9. Multi-word expressions. Idioms, compounds, phrasal verbs, collocations. SAGE 2002. A pain in the neck for NLP. The whole is not the sum of the parts. Fix. Store idioms whole. Problem. The lexicon keeps growing. Modern transformers half-solve MWEs, but fail on translation and sentiment. Lecture 8 Preview. We leave the sentence behind. Document-level tasks. Summarization. Turning 10 pages into 10 sentences. Machine translation done right. Translating in context, not sentence by sentence. Discourse structure. How paragraphs connect. Automatic speech recognition. Text from audio. Text to speech. Audio from text. Dialogue actually talking with the machine. 10 more videos. 3 takeaways before the quiz. 1. Lecture 7 walked the classical NLP pipeline end-to-end, 9 tasks, 9 papers to know. Every one of them still runs, either as an explicit spacey step or as an implicit signal inside a transformer's hidden layers. 2. The pattern was consistent. Every task was cracked partly by classical algorithms, then advanced by neural models, then finished by transformer pre-training. WSD, Coref, and MWE detection all got solved sideways this way. 3. Everything up to here was sentence level. Lecture 8 opens the document level layer. Summarization, translation, speech, dialogue. The next 10 videos are where NLP meets the real world. Quiz 1. In the classical NLP pipeline, which task comes after named entity recognition and before semantic role labeling? A tokenization, B word sense disambiguation, deciding whether bank means river or financial, C POS tagging, or D Coreference. B. The belt goes. Tokenize V2 POS tag, V3 parse V4, N year V5, WSD 6 SRL 7. WSD sits between N-year and SRL Coreference, and MWE processing are the edge cases beyond the belt in VATE and V9. Quiz 2. Which pattern kept repeating across Lecture 7 tasks? A classical algorithms won every time. B. Every task was cracked partly by classical algorithms, then improved by neural models, then solved sideways by transformer pre-training. C. All tasks required custom handwritten rules. Or D. Every task remains unsolved. B. This was the through line. POS, NER, WSD, Coref all followed the same arc. Rules: statistical neural transformer, WSD, Coref, and MWE, handling especially got solved sideways as side effects of language modeling pre-training rather than dedicated task engineering. Quiz 3. What kind of tasks does Lecture 8 open up? A more sentence-level analysis. B. Document-level tasks, summarization, machine translation in context, ASR, TTS, dialogue, beyond the sentence. C. Only computer vision, or D. Only reinforcement learning. B. Lecture 8 leaves the sentence behind. 10 videos on tasks where the interesting structure spans paragraphs or entire dialogues. Summarization, discourse, translation in context, speech in and out, information retrieval, question answering, and RAG. Back to the puzzle. Lecture 7 bridged the linguist's view, a pipeline of tasks, and the engineer's view, one transformer. Both true. The pipeline is the shape of language. The transformer is how we compute over it. You now know both. Onward to Lecture 8, where language stops being one sentence and starts being a whole conversation. Next lecture. Lecture 8 opens with the document-level puzzle. Why summarizing a 10-page paper is not just parsing 10 pages one sentence at a time. Where sentence-level tools break, and what replaces them. Hit subscribe.